Good afternoon, everybody. Welcome to the Qualogy Tech Series, episode 4 already. Today we have Keith Laker with the introduction to solving SQL problems with Match Recognize. Keith is product manager for autonomous databases and analytic SQL, just about anything analytic. Been working for Oracle for almost 20 years. And I think you'll have something very interesting to tell us. So, Keith, if you take over the screen, it's all yours.
Okay, thank you, Patrick. Okay, start share. Share that one. Okay, hopefully that is now visible.
Yes.
Okay, good. So yes, thank you, Patrick, for the invitation to talk to everyone on probably what is my favourite subject, although I spend a lot of my time these days on autonomous database. I do love playing with SQL, and pattern matching is sort of one of my pet areas, and I've put a lot of time and effort into exploring the wide aspects of this. It is a very, very deep feature. I could talk to you for several hours on understanding the sort of inner parts, inner workings of Match Recognize and how you can get the most of it. But today I sort of want to start at the very top. Patrick's very kindly offered to monitor the Q&A and chat. So if you've got any questions, throw them into, I guess, the Q&A channel, and Patrick will interrupt me on your behalf so we can cover questions as they come up. Hopefully this will all be self-explanatory. Well, I will make the content available to Patrick afterwards. So a quick introduction. As Patrick said, I am part of the product management team for both Analytics SQL and these days more focused on autonomous database. Consequently, I have two Twitter handles at the moment. One that focuses purely on SQL, and the other one which is focused more on autonomous data warehouse or autonomous database now. But you can kind of track me down on either of those. I'm also on blogs.oracle.com as well, so you can find me through that. When SQL pattern matching first came out, actually, has anybody tried pattern matching? I think we can do sort of raise hands or something using the button in the Zoom thing. It's been interesting to know if anybody's actually tried using SQL pattern matching yet. My guess is most people probably not. And that's kind of what I think I'm seeing here. Okay.
Not much response.
No, that isn't surprising, because I don't think many people typically would think of using SQL to do this type of operation. There are lots of different languages out there which are more geared towards doing pattern matching. But as I'll explain later on, this has actually been in the database since 12c. As I said, this is a really big topic. It's one of those SQL functions. The more you get into it, the more you realize what exactly it can do and how you can use it. And I think one of the joys for us in product management, and also for my development team at HQ, is that we've seen all sorts of really interesting use cases that we never envisaged. And probably one of the biggest proponents of documenting all these really interesting, unique solutions using pattern matching is Stu Ashton, who I'm guessing probably a lot of you already know as Stu is in Europe. And some of the content here has come from discussions that I've had with Stu and seeing other content that he's delivered at various conferences throughout Europe and to an extent the US as well. So after sort of initially diving into pattern matching, I decided to try and put together, because I spent a lot of time with different project teams doing POCs and things, and sort of expanding my knowledge of how to use this. And I tried to wrap it all up in a book, which you can get in either iBook or PDF format. I'm desperately trying to get volume 2 done, which goes into sort of more the DBA centric stuff. How do you get inside this thing and work out what's going on? But this is kind of a good starter. It's got a lot of good use cases. There's a lot of good code, and so on. So the link will be in here, and you'll be able to explore it at your leisure. So I'm going to sort of go through quite a bit of code here. Hopefully it will be self-explanatory. I've tried to keep the examples fairly simple, just to try and keep the amount of code down. But we're going to get into some important areas. So I guess the first thing is, what is match recognize? How do you get into it? I've said this is sort of a high-level code. If you flip over to livesql.oracle.com and do a search for match recognize, you'll see there's lots and lots of different coded examples already on LiveSQL, and I'm going to kind of go over a couple of them today. So, for example, getting around the long list problem, the list egg problem in Oracle database, where we get a string that's far too long and it just blows up the list tag function, and you're kind of stuck unless you go searching for Tom Kite's various solutions to the problem. Here's actually a very simple, elegant one here. Okay, so just to step back, database 12c got you this new native SQL construct, which is called match recognize. It does appear in some other databases. So because it's part of the ANSI 2016 SQL standard, you will find it in certain other databases out there. However, most of those databases have not implemented it to the level that we've gone to inside the Oracle database. How you use match recognize, I've seen a lot of different presentations at different user group sessions, and people have sort of their own pet way of explaining, okay, this is how to think about building up a pattern matching clause. But this is how I think about it. So I sort of group things myself when I'm tackling pattern matching problems into 4 areas. First is, if you're used to analytic SQL, the window clauses, you'll be immediately recognize things like partitioning and order by syntax and how that makes sense in a pattern matching process. Then we actually get into the core of it. What is the pattern? What am I looking for? And how am I looking for it? How often do I expect this pattern to appear? How many times do I want it to appear versus within a particular range? Having found the pattern, then, what is it that I want to get out of that pattern? What information am I looking to pull out? What type of calculations do I want to do on that data set? And then finally, there's the shape of the output. How much information do I want back, or how little information do I want back? So there's various key words that we're going to have to build up when we introduce match recognize. So the first part is, if you're used to window functions, you have to, well, you don't have to, these are optional, but it's always useful to think about partitioning on a particular column or set of columns, and also ensuring the date or the data set that you're going to work on is correctly ordered. And usually these are the two first building blocks. And in most of the examples that we're going to look at, those two elements there are the first things that we have to put in. They're not mandatory. You can ignore them and just will accept the defaults, however the data is presented. But bear in mind that your results may not be deterministic. So it's always good, don't ever assume anything. Make sure that my recommendation is treat partition by and order by as mandatory to make sure that you get deterministic results. The next thing we need to think about is defining what we call pattern variables or events. And we follow a similar example to Perl, where we can set the number of times that we want to find something, i.e. the frequency of the match that we're looking for, and also defining what the match looks like. What does it consist of? How do I know I've got a match? In this time, I've got, say, the current time, I'm looking for an interval of 10 seconds, and that's got to be greater than the previous time, and so on. But we'll see some examples of this in a minute. The next thing is, okay, what is it I want to pull out? What data am I looking to get once I've found a particular match sequence of rows? Things like the match number, how many matches have I found so far in my pattern matching process? Which variable, the classifier, have I found? I can do various operations like extracting the first value or extracting the last value. And these are, you can get a bit deeper into these two aspects as well, because they allow you also to point to different rows within that. So I could actually say first value 5, and it would go to the first value and then jump forward 5 rows. Or I can say last value 3. I'll go to the last value and then step back 3 rows. So you've got some nice ways to peek and poke into this data set to pull out various pieces of information that you want. And of course, you can do computations. So I can say first value minus last value, or last value minus first value, whatever it is that you want to do. And then the last step, as we'll see, is, okay, do I want all of the data returned? Do I want only my matches returned? Do I just want a summary report? So let's dive in. The first one that we're going to look at, those of you who've been with Oracle, probably a while, if you can cast your minds back to the days of big data and Hadoop appliances and all that, and the big data light virtual machine that we used to bundle up and pass out on OTM. And you can still find it on oracle.com, it's still there, available to download. There was a weblog in there from the Movieplex app that we had, which contained information about user sessions. And what we wanted to do was create a SQL statement that would, in effect, do a sessionization of that data. Now, you can do this elegantly, quite elegantly, using analytic SQL functions, but it tends to be a multi-pass operation to work through that data set. And it's quite complicated. It's a lot of code, but you can get an answer out using standard SQL. What you'll see here is it's actually very, very simple and elegant to do this now with match recognize. So if we look at the data set, take a very simple data set. I've got a time and I've got a user ID. So first thing we want to do essentially is work out how many sessions per user. So if we just scan down that list, for example, Mary has 2 sessions. Mary has a number of sessions. The first one has 2 entries So 1 and 11, which equates to that one. Then she has a session that starts at time ID 23, and then she has another one that starts at session 34. Now, what you can see here is, okay, I've got 1 to 11, and then I get a break. So effectively, I have set up a requirement for a specific time gap between events happening that get written to the log. So I've said essentially, if the time gap between events appearing for Mary is greater than 10, then I'm going to assume she's maybe gone off somewhere else, and we're going to treat that as a different session. So the next time she clicks at point 23, that's more than 10 seconds from the last time she clicked, or 10 minutes. And we're going to treat that as Mary started a new session. So we can process that data set quite easily, and then we can start to pull out information based on that data set. Okay, what time did she start? What time did she end? How many events? Was it 2, 1, 4? And what was the duration? What was the end time minus the start time? So there's quite a lot of computation going on inside that example. So how do we put this together? We start with adding a new keyword on after the from clause. And just to be clear, this could be a table or a view or a select statement, and we'll look at this in example 3. But essentially, this is the input to match recognize. So when we say select star from A, I am not pulling out specifically columns just from table A. I'm essentially going to be reaching into a much wider data set that's going to return not only the columns from A, but the measures from within the match recognize clause. So think of this as your input into the pattern matching process. So that's the data set that I'm going to pass in, a table or a view or a select. Okay, I need to, if we go back up here, you can see I've got Mary, I've got Sam, so I've got different users in here. So essentially what I've got to do, if I just want to see what Mary was up to, I need to split this by user ID. So I need to partition by user ID, and then to make sure that I can understand the difference between the different time events, I need to order by time. So that's what you'll see. Partition by user ID, order by time. So that splits up my data set. The next part, okay, I now need to determine what my pattern is. So I'm going to say I want 2 elements to my pattern. I'm going to have element B and element S, and S is going to be my session. And I've got a plus sign. So the plus sign indicates that I am looking for 1 or more matches. And in the same way that you can do with Perl, you've got a range of these regular expressions that you can use. And depending on the type of problem you're trying to solve, you can use these different combinations, including what we call reluctant quantifiers, which I'm not going to get into at this point, because that would be a whole different topic. Could probably spend an hour talking about reluctant quantifiers. But I have a specific blog post on this that I would suggest if you want to get deep into pattern matching, go and have a look at that blog post on reluctant quantifiers. Okay, so I'm going to go for an event called S. I'm going to look for it on 1 or more matches. But what does S mean? So I am going to say that for a session to be, or an event to be part of an existing session, the time ID stamp minus the previous row's time ID must be less than or equal to 10. So I'm going to say there can be a 10-minute or a 10-second, however the timestamp is set up. There's a difference of 10 between the current time and the previous record. And you can see I've got this function that I can use to call previous to step back a row, pull out that value, and that's going to be what I'm going to compare to. We'll come back to this one in a minute, but bear in mind, as you can see, it's not currently defined. Effectively, it's an always true event. Okay, so I have a pattern. I know what I'm going to search for. This thing here that we're not quite sure about yet, S plus. So S is defined as this time width, and I'm looking for that one or more times. Now I have to say, okay, what information, having found a user, am I looking for? And if we look at that report that we pulled out, I want the user ID. I want the match number. So effectively, that's going to be my session ID. So match number 1 will be the first session in my count or my process, and then 2, then 3. The number of events within each session. And then I can take the first instance of the time value that we found from here. And this will effectively be an always true event. That is my start time. My last time is the last occurrence that I get from matching these rows, this pattern requirement. That will be my end time. I can then calculate or compute the duration by taking the last value minus the first value. Okay. Let's just step back. So what's going to happen is, effectively, I am going to go in here into this data set. We'll take out Sam. We'll just focus on Mary. The first row is going to get matched to B because B is always true. So I'm on a match. Row number 1 is in play. I then go to the second row. It has a value of 11. So now I say, is row 11 minus the previous row, the time ID on the previous row 1, greater than 10? And the answer will be yes, this falls within my date range, sorry, less than or equal to 10. So it will fall within my date range. So I can conclude that row 2 is also in play. So now I've matched 2 rows. I now go to the next row. And I say, okay, is 23 minus 11 less than or equal to 10? No, it's not. Okay, the system now knows that we've completed the first match. I can now sign off the first 2 rows as having session ID or match number 1. And this row now becomes the starting point for my next run through to pick up, okay, this is session 2. And then I go to the next one. Okay, session row 4 is the difference between those 2. Less than or equal to 10. No. Okay, so now I start another session. So this is now number 2. This now we've upped the increment counter. We're looking on session 3 and we start looping through these rows and so on. So that's how it works up to this point. Now, in terms of the output, we can do 1 row per match, which in effect is what we have back here. So if I go back here, I've got one row per match. Here's my match, which is my session ID, and I just get one row back. If I was going to do all rows per match, I would get essentially something like this back. Every row would contain the details of the match that had occurred. So depending on the level of detail that you want back, you control that by these three options here. And certainly when you're debugging, it's always good to start with this one. Give me all the rows per match with the unmatched rows, just so that you can make sure what you think is happening is actually happening. And it's always good to have three data sets, one that you don't know about, one that you know contains a set of matches, one that you know contains no matches, and then run your pattern matching program through those three data sets and check to make sure that your pattern is actually doing what you expect it to do. Okay, the next and the last bit is to think, okay, where do I now start to look for the next match once I have found a match and completed a sequence? So I can go to the next available row. I can skip to a particular variable. This allows you to control you to be able to look at overlapping patterns. So it's this bit is getting kind of sophisticated depending on what you want to do. Essentially, that is an optional one. And you can largely leave that one to sort itself out if you're not doing anything particularly sophisticated. If you want to get into the levels of sophistication of overlapping patterns, then start looking at the skip options. There is that whole sessionization flow is available in Live SQL. You can run through it, and you can see I put this up in 2017, so it is quite old now, but it's quite useful. It does run through a good example of how to just get into and understand sort of part of the power of what you can do with pattern matching. Okay, this one, that's sort of a typical, I'm going to say, business operational type example. I've got a weblog. Sessionization is typically, certainly in the big data days when we had Hadoop clusters on premise, that sort of job you would have just thrown at a Hadoop program, written a ton of Java and be done with it. The nice thing now is that you can take that source file, that log file, and effectively just use a couple of lines of SQL to do the same thing that would have been 150, 200 lines of Java code. And of course, if you move it up to the cloud, it's even easier because you can just access that file directly from an object store and run SQL straight over it from within the object store. So this one is from a problem that I think was pretty hot on Ask Tom for a while. Tom Kite got this question about what to do when list tag contains too many values. Now, the good news is this is largely redundant now. In 18C, we added, I think it was 18C, we added some additional syntax to list tag to control errors. So you have complete control now over list tag when you've overrun the maximum string size for the database setting. But this gives you kind of an interesting way to solve that problem without getting into a lot of complex code. Now, Tom put up some quite interesting examples. And I kind of took that and thought, I think we can probably do that pretty quickly with match recognize. The nice thing about match recognize is you have complete control over the length of that string. So never mind 4,000 characters or 32,000 characters if you're on 19C or 21C. This one gives you the option to, for example, set it to be 15 or 20 characters max, depending on, if you've got to put this up on a particular width of a field on a form in a web page or something, or in Apex or whatever it is. So what I want to do is go down the departments and then concatenate the e-names based on a set maximum length that I'm going to go to. And then I can parse over the top of that and do some things with listag. So the first thing we've got to do is we need to obviously partition by department number and then employee number and order by employee number. Don't actually have to order by anything in this case, but I always like to make sure that the output is going to be consistent every single time. So in this case, I did emp note, could be e-name, could be job title, hire date, whatever it is that you want to use as the order by clause, but try to pick something that is going to be deterministic. So the next thing is pretty similar to the last one. So again, I'm going to look for one or more matches of B, and I've defined B as this sort of quite lengthy formula where I effectively take the length of the name, the first name, and then add up all of the next set of e-names with a comma stuck on the end of it, plus the length of the comma, and that's got to be less than or equal to 15. And I want to know what the match number is. How many matches do I get per department where I overflow 15 characters in length? Now that 15 could be anything. If we were looking at trying to reduce errors in listag, it could be, say, 3,980 to keep you under the 4,000 limit, or whatever it is. So you've got complete control now over the maximum list, width of list that you're going to generate. And in this case, I actually need to get every single row back. So I don't want a summary. I actually need to get every single row back because I'm going to pass this into a listag when it's finished. And just for completeness sake, I'm going to say once you have found a match, then skip past the last row of that match and move to the next currently unmatched set of rows or unprocessed set of rows. So that is the default. That's why I'm saying you can actually ignore that in the vast majority of cases. This will effectively answer most of your problems. Where you've got overlapping errors or patterns that you need to find, then you're probably going to have to dip into this toolbox and try and think about how you can reposition the pointer to be able to start looking for that overlapping pattern within your data set. And there are examples where you actually do need to go back over and step backwards through the result set that you've already processed to be able to start looking for the next pattern. But so what we get is output something like this. So I get the department number, the employee number, the match number, and then I've got all of this. So you'll see that I can add Clark and King together with a semicolon between the names, and that will get me to less than 15 characters. If I then try and add in Miller with a semicolon, I will go over 15 characters. So Miller becomes not part of the first match, but now becomes a completely new match. And for department 10, I'm done. For department 20, I can add Smith and Jones together with a semicolon between them. If I try and add Scott, I actually go over 15. So now Scott starts as my first element in my second match. I can add Adams, and again with a semicolon, do the count. That's looking good. I then get to Ford. Ford trips me over 15, so that becomes my second match. Ford now becomes my third match, and so on. So these essentially, by setting up partition bys, effectively we're parallelizing our operation. So I've got parallel operations processing department 10, department 20, and department 30. So that's another useful reason to try and have a data set that is also partitioned so that you can get parallelization going on under the covers. That's the column that we're actually interested in. What is the match number? Because then I can do my list tag based on the department number and the match number. And you can see that none of those, when I concatenate these, none of them go beyond the 15 characters that I actually asked for. So this is now, I'm going to say, redundant, because we fixed this problem in list tag, assuming that you're on, I think it was 18C where we added that. And there's also some nice additions that we added in 18C, like telling you how many values we truncated and so on. You could replicate all of that functionality inside pattern matching as well. But essentially, this problem kind of goes away. But it's a nice, interesting look inside of pattern matching to try and help you resolve a kind of developer problem that you might see. Okay, the last one is one that Stu Ashton began talking about, which is contiguous date ranges. How do I know whether a block of data that I've got has a contiguous date range, and most importantly, how long was that contiguous date range valid for? So if we look at the standard sales history schema, you've got a sales table, sales fact table, you've got a dimension table, and we also want to combine that with channels. So what I want to know is, for a specific channel, what was the start date for the first element of the pattern where I've got a contiguous date range? What was the end date, and how many days were in that contiguous date range? Now, this, I think, is typically used in ETL type processing, particularly where you've probably got staging data and you're trying to do comparisons. Now, in this case, the reason why I've chosen this one is because here you can see, rather than passing in a table or a view, we're actually going to pass in a select statement. So this is going to be the input into the pattern matching process, for which I'm going to pull out the start day, the end day, and the count of the number of days between the end date and the start date. So again, for completeness sake, I'm going to set up a partition by clause based on calendar year. I'm going to order it by day ID. And my pattern is going to be, I'm going to look for one or more instances where my A pattern, where the previous day plus 1 is equal to the current day. As long as whatever the row I'm currently on, as long as the previous row plus 1 equals that, I've got a match, and I've essentially got a contiguous range. And then I'm going to pull out the information that I want, which is the first day that I find, which in effect is start.day ID. So here I'm pointing to a specific value. Before, in the earlier examples, we didn't do this. We just said first day ID. Here we're being very, very specific. I am pointing to a specific variable to pull out the day ID. And the last day ID will be acquired from whatever's contained within the pattern of A. That will be my end day. And then I can count all of the days. So I don't have to worry about whether it's an A pattern day or a start pattern day. I can just say, give me a count of the day IDs. And what you will get, we'll do one row per match. So I'm not interested in all rows. I probably, if I was going to test this, I would probably do this. I would probably do all rows per match, possibly all rows per match with unmatched rows as well, just to check that this pattern is actually doing what I think it should do. But I'm just going to say, yep, okay, I'm pretty confident with this one. It's fairly straightforward. So as I go down through the data set, I've limited this to one channel. I could do this for more than one channel and see if there are any observable patterns between different channels as to date ranges that might come out, might get surfaced. But for the channel that I've selected, the first range is from the 1st of Jan to the 28th, and it's like 59 days. The next block is from 2nd of March to the 6th of March, which is 5 days, and so on. So it's very easy now. You could, again, do this with analytic SQL functions using window functions, but it's probably going to be a multi-pass operation, and it's actually going to be quite a lot of code and probably quite processing intensive. The nice thing about SQL pattern matching is it's very efficient in the way that it uses resources. Again, there's a live SQL example. You can go and play with this yourself. If you've got the sales history schema installed somewhere, you can also just play with it on your laptop. So these are the typical types of problems that you can now resolve quite simply internally within using SQL, as opposed to writing lots and lots of PL SQL code, or worst case scenario, exporting all the data out and doing this in Java or Perl or whatever your favorite pattern matching example is. One of the probably more interesting aspects of this, and this is when we originally launched pattern matching, we did an example at Open World, is that because this is now inside SQL, you've now got access to not only pattern matching, but you can do pattern matching within the context of a spatial query, So the example that we used at Open World was credit card transactions. If a credit card is used in one location and then used in a different location, you could use spatial to work out the distance and then determine, however you want to determine what business rules you want to apply. Okay, based on those 2 points, what is the probability that that is a fraudulent transaction? So you can start to bring in other SQL capabilities in a typical converged database example. Another one that I did recently with Hans Veerman using Graph. He was using Graph to explore transactions, and based on relationships that he was finding within those transactions, I could then put pattern matching on top of those relationships to look at the transactions that were going on and work out whether there was likely to be fraud based on the rules that the customer had given us. So the really nice thing here, if you were having to dump this all outside and do it in, I don't know, Java or Perl or whatever your favorite language is, that would be a two-step process, and probably quite tricky to do, trying to match up, for example, spatial or graph type queries and putting data out to then go and do pattern matching and then sucking it back in and trying to make sense of what it is that you've just done. The reason why that we went down this route, obviously it's an ANSI standard, so we were extremely keen to bring that in. But we had a lot of mobile companies, telecoms companies, asking us again to help them reduce the amount of code they were having to write to do what they considered to be quite simple operations. And not surprisingly, one particular mobile company asked us to help them identify situations where SIM cards were just effectively being popped in and out of different phones and moved around. So rather than being able to sell someone 10 SIM cards, that person bought one and then moved it around different phones within their family. And that, for them, was considered to be unacceptable behavior, unacceptable use of their SIM card. And they wanted to find those and just contact people and say, okay, have you thought about getting extra SIMs? They had their own SQL code. It was a lot of code. It was multi-pass and it was quite slow. By using Match Recognize, they significantly, by huge orders of magnitude, improved the performance of their processing to be able to do this type of analysis. So there's lots and lots of different types of what I would call business type operations. But there are lots and lots of other ones, and people like Stu Ashton's very good at digging these out, where there are patterns that sort of occur from a DBA perspective that you're interested in, or from a developer aspect that you're interested in, such as, how do I work with contiguous date ranges? How can I identify groups where I've got contiguous date ranges? That was sort of one of Stu's one. So I would say look at the typical business operations, but also keep a mind open to everyday situations that you find yourself in, and you can all of a sudden see, if that looks like a pattern to me, I could probably use that with SQL pattern matching to try and help me solve that situation. We're finding more and more of these use cases that we hadn't thought of that people are bringing to us, and it's really interesting. Again, one thing that's come out, please, when you're using it, think about how you'd like to see additional features in this tool. So one of the examples that I've got from Stu is, if I'm doing a searching for a pattern, I might actually only need to know that a pattern has occurred. I don't need to know how many times it's occurred. Effectively, as soon as a pattern happens once, that's all I need to know, and I could then stop processing. So one request that we've got, I've submitted the ER, is a stop after capability within the pattern matching syntax, which is kind of interesting because, again, we hadn't really thought that. We just assumed that once you'd started searching, you'd want to search to the end of your data set. But apparently there are instances where you only need to know that it's happened. And then that's it. Okay, I can stop at that point. I know it's happened and I can park that. So think about when you're using it, are we missing features? Are there things that you'd like to be able to do with pattern matching that would be simpler if I had this syntax, or if I could do X or Y? So it's a pretty fast run through. If you want to get deeper into it, what exactly is going on underneath the covers when we're doing all this matching? How are we going backwards and forwards over rows? How can you track it? What are some of the pitfalls that you could get into? There's a lot of blog posts that I've done, and there's also a lot of information in that book that I mentioned at the start. And of course, you can always ping me through email or through the blogs or Twitter or LinkedIn, whatever is your media of choice, and just throw problems at me and see if I can help you out. And I'm always interested to find out what people are up to with this feature, because to me it's absolutely incredible what you can do with it. But I'm always interested to see what other people are trying to do with it. And I always like a problem to solve, particularly with pattern matching, because it is very, very exciting to play with. So I would say go forth and use pattern matching as often as you can. It is powerful. It is extremely fast compared to trying to work in other languages or do it using standard non-pattern matching SQL, which you can do in a lot of cases. Some cases you can't. And also think in a wider context, think in a converged database approach of, could I get extra value out of this by combining it with graph or spatial or machine learning to that extent. So that's pattern matching at probably 200 miles an hour. I can see Q&A and chat seem to be fairly quiet. Which is maybe a good thing. I don't know, but hopefully that all made sense. Patrick will, I presume, make the content that I've got here available to you.
Yeah, if you send it to me, and
okay,
I will make it available to all the participants. So thank you, Keith, for a nice introduction to pattern matching. Match recognize. I hope you've all enjoyed it. And I hope to see you again next week when I'm going to be presenting. So, yeah, I hope to see you there. And thanks again, Keith.
Okay, thank you.